Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good morning, ladies and gentlemen. We're going to start this, our last session of keynotes of the Paris Software Summit. And it's my great pleasure to be welcoming on the stage Brendan Eich from Mozilla Corporation. Brendan has a very distinguished career, and he is the Chief Technical Officer of Mozilla, and he's widely recognized for his enduring contribution to Internet revolution in the 1990s. He's also the person who invented JavaScript, which was called ECMAScript in the old days, and it is the most widely used programming language on the internet. It's one that we are constantly watching in Microsoft, and it's probably one of the reasons why we were very keen to have Brendan here today, because it is important that we know about these things and what the future is going to bring with this kind of language. Of course, the focus of this session is on open source, and Brendan is an expert on that because he heads up both the Thunderbird and the Firefox web browser projects in his role as Chief Technical Officer, and no doubt he'll be telling us a little bit about his war stories and experiences in that regard as well. So please welcome onto the stage here, Brendan Eich.
Hi, thanks for having me. Thanks to Judith and Wolfram and Peter and everyone. I had a choice. I could have been at another event in Las Vegas, and I think I chose the better course. It's kind of the silly season, so you'll hear a lot about HTML5, and it sounds like the latest and greatest thing ever. I'm not going to talk about that much. I will tell a few stories. I feel fortunate to have the chance to do some research with some of the fine PhDs we've hired at Mozilla and people I know at places like MSR and many academic institutions. I did not get a PhD. I was at the University of Illinois at Champaign-Urbana 10 years before Mark Andreessen and that lot, and I was on a project IBM was hijacking to do QA in a desperate attempt to get a product into the workstation market. So I heard Jim Clark, who founded Silicon Graphics and then later Netscape, come and speak, and I said I want to work for him, so I did not get a PhD. But now I pretend to do research, and I work with some very smart people. And I see acutely some problems that I think you all see and work on. And I appreciate the approaches here I've seen, like Verifast and F7, and I like them a lot. We've been using the ML languages, SML and OCaml. We haven't quite used any of the big methodological frameworks to do proving, but I respect that. It's just very far from the world I'm in. I'm in the world of producing, through open source techniques, working for a nonprofit, competitive web browser. And correctness is obviously a big problem. Security is a concern. We're facing the many-core future. So there's a problem statement I want to make, which won't be news to anyone here, but I'll try to put my own individual stamp on it. And I'm actually going to pick up on something that was presented just last week at a conference in San Francisco called CodeConf, which is a new conference. It's associated with a site called github.com that I'll talk about later. And one of the speakers there is a very bright young man I met recently named Jeremy Ashkenazi. Works for a nonprofit called Document Cloud. He's created a language called CoffeeScript that translates to JavaScript. He's very smart. He seems to be mostly self-taught, and he's a Rubyist, which is interesting. But his talk at CodeConf was really about what makes code strange. Why is it different? And he talked about how code has a literary aspect because it's written not just for the machine, which has to do what you say, whether it's what you meant or not, but also for other readers. But he also he made a little play on a little devil on his shoulder and a little angel, and he didn't say which was which, but it was pretty clear after a while which was. One was Dijkstra, and he gave Dijkstra due credit because I think Dijkstra's statements here are true, and they provoke a different response from different people. Some people say, well, because the automatic computer is so radically different, we should not bring anything with us. Like Dijkstra was not in favor of anthropomorphizing. So object-oriented programming, as Alan Kay developed it, would be anathema. And Dijkstra said you have your proof next to you when you write your program. This doesn't seem to be succeeding in industry. This is something that is, again, I admire and it's useful and it's important to do in critical code, but it's difficult. And the angel, I think, in Jeremy's shoulder, in his view, was Don Knuth, who was talking about how there's an aspect of programming that is like an art. And I'm not going to repeat everything Jeremy said. His thesis is a little bit more about the artistic or literary aspects of programming. But my point is that programming still is intensely human, and therefore it's intensely social. And so all our attempts to automate it have a long way to go. We can't really automate the writing of programs to any significant degree. We can automate reading of them, which is very interesting, something Mozilla is invested in. We are invested in automatic program analysis, and I'll talk about that. But the reason we're doing this is because of this huge problem that programming is quite difficult. Correctness is elusive, and things like hardware parallelism, data races are very troublesome. Security for every browser vendor that uses an unsafe implementation language is an eternal struggle. And yet we're all competing to be the fastest. Well, Mozilla doesn't say we're the fastest. We're the only browser vendor that says we're not the fastest. So maybe we can afford to take the hit of security. Actually, you can't. If you're competing, you really do have to be very fast, even if you're not saying you're the fastest. And what I observed is this scales up badly. Of course, 10 to the 10th from gates up to the loftiest abstractions. But then over time, it scales badly, and over people. Large code bases are troublesome. And over time, they tend to suffer the usual problems, path dependence. That you build platforms on top of substrates that you didn't fully understand, and then you start stressing them in new ways, and you find bugs, latent bugs in the system. We've all seen this. Anybody who's worked on an operating system sees this. Browsers have layers within them. Layering does not always solve problems. Sometimes it just adds problems. Abstraction is powerful, but too many layers can just create opportunity for bugs. So to solve this time problem, you want to revisit your code. You want to rewrite it, but that's the rookie mistake. You can't really just rewrite it all the time, all at once. And you shouldn't rewrite the parts that aren't in bad shape. So it takes some nice judgment to know what to rewrite, and yet sometimes if you're a really good programmer, you can patch the dike for a long time past when you should have rewritten it. So, oops, let me go back. I think that's accurate. I'm not sure if I have that quote quite right, to Ken Thompson, but there's deep truth in that. Why does code rust? It's not oxidizing. What's going on? It has to do with people. So the person who wrote it meant something. Whether the code said that to the machine and caused that meaning to obtain is one thing. And then whether readers saw that meaning or saw some other meaning they wished is another question. And as you build platforms, people do create new requirements on your old code. They do perhaps find serendipity. They find something that happens to work and they exploit it. Or maybe they see something that almost works and they miss where it doesn't. So code needs to be constantly turned over. And that's another human aspect, another sort of social aspect. You can't just leave it alone as a perfect jewel. It really isn't. Maybe something in isolation for which you've proven correctness. But code that's used tends to be changed or be layered upon, and that causes it to need to be tended. So I'm going to run through Mozilla history. I apologize for some of you who know this, but it might be worth going from my experience. My method's pretty inductive here, and I don't have answers. I don't know if anybody does. But what I've been through has affected me in ways that I think are not just peculiar to us Mozillans. We started from Netscape's decline as a sort of a last-ditch attempt to get the code out there, maybe just as a legacy. And we we spent a good time operating as a virtual organization. We didn't have any legal entity for our trademark. We didn't have any separate autonomy in any sense. Those of us who worked for Netscape and were part of this virtual organization's staff reported into the Netscape and then the AOL and Time Warner hierarchy. And there were people on staff who were also working at other companies like Red Hat and Collabra. So there was a good mix of people, a little Netscape dominated, but we acted as if we were independent. I remember using my own laptop, which I bought for myself, and using a Ricochet modem, using my own network sometimes to avoid sticky-fingered IT people. And I tried to act as if I were a volunteer contributor to the project. I did not act as if I were a privileged Netscape insider. And that went on for a while. I should mention Mitchell Baker, who's a woman, is my colleague of many years, who is the creator of the Mozilla Public License, which is our weekly copyleft open source license that we use. We now use it in a tri-license form. We're also open to other licenses. Open source licensing is sort of plagued by religious arguments that aren't that important to me, so I'm not going to get into that. But Mitchell handled governance and process, and I handled technical architecture and leadership and arbitration. And all our work was heavily delegated. At first, it was delegated to people who were, all of them, every single one on the day we open sourced, employees of Netscape. And that's another social problem, because when you have people working for Netscape who have all the power and the keys to the kingdom, and you're trying to bring volunteers into the project, the volunteers may be motivated to get their code into Netscape, but they may also expect to be treated fairly, and it may be hard for them to be treated fairly if they're not employees. So we had to fight against that constantly. But volunteers did come. We had a few interesting hacks. Someone substituted open source early version of what became OpenSSL. I think it was called SSL-EAY, whole open source crypto module for what we were unable to release at that time in 1998 because it was an electronic munition, which was the Netscape crypto module. We eventually were able to release that. And a few other tricks like that were done, but the code was Netscape's from 1994. It had been hacked over many times, and that sort of Rust process I mentioned had happened. So it was hard to hack. It was fairly messy, and we didn't get a lot of uptake. So I said in October of '98, let's rewrite. I had an offer from a group inside Netscape, an acquisition that had been working on a new code base for a cleaner layout engine, and they said, we'd like to be the center stage in your open source project. And we saw that the old code was just too messy to get volunteers to really engage with it. So this is something Joel Spolsky says you never do. You never rewrite everything at once. And he even wrote an essay around 2000 saying, oh, Netscape's committed suicide by doing this. They could have been in the market. They could have been shipping a Netscape 5 against IE5. I'm not sure it would have mattered. There were many mistakes made at Netscape, and whatever Microsoft did, it might have been inevitable. But what we did was we made greenfield development space for volunteers. And that was intentional, and that was successful, though it set us back 4 years. And it cost some of the management in Netscape their heads, because they kept saying, well, any year now, any month now, we'll be competing with IE, we'll be back in the game. And we'd taken the long way around, because we were rewriting a large part of the code base, not quite all of it, and we were making it open to volunteers who wanted to contribute to it, because this new engine, Gecko, was really not quite ready. It was like my first layout engine. It was doing CNN.com and so on, but it was not really ready for the huge, huge breadth of the web and all the content that was on it even then in '98. So we were also focused on web standards, which were very important to the volunteers who were coming to us. And Netscape's old code base wasn't very good at web standards, because it, in many ways, evolved before the standardization wave that resulted from the competition between Netscape and Microsoft. So this was a calculated move, but it cost us. And it meant that Netscape, which was under pressure to show that they were a worthwhile acquisition to AOL, went and shipped something that was pretty much a flop. And that was Netscape 6. I don't know if anyone remembers it. And to show that we didn't think it was ready, we actually kept our Mozilla milestones numbered below 1 on purpose. And this caused some raw feelings, but we had the whole community and even a lot of the employees on our side. And we were getting more volunteers over time. So I don't have the numbers, I wish I did, but we were getting minority representation that was growing of volunteers to the project who were actually significant technical contributors, not just testers, documentation writers, but actual coders. In 2000, 2001, 2002, the worm turned. Netscape 6 was a flop, and we actually took that opportunity to say enough of this sort of privileged employment status shenanigans, because Netscape was still hiring people who wouldn't necessarily pass muster according to this meritocratic sort of open peer review process that you do every day when you work on an open source project, where you're looking at people's code and you're interacting with them on a chat channel and you're sort of sizing them up. Some of the Netscape hires weren't that good, and they had to wait for their commit access to the source code repository. We made binaries available early on for testers, because even if testers have a compiler, running a build process is an arduous thing. It was a controversial decision at the time. I think Jamie Zawinski, my Mozilla co-founder, thought, no, you shouldn't download our code unless you have a compiler. And I think he was wrong. I think we did well by producing binaries so that testers and even users could start to use our somewhat under-branded open source product. And it was a product, and it did get used, and in fact, it started competing with Netscape. And I started writing roadmap updates to try to move the project toward its 1.0 milestone. When we thought we would have a good enough code base, we would have a set of APIs that we could try to keep backwards compatibility on as we move forward beyond that point. These are all historical documents I've linked to, and I'll put these slides up. And that plan was going to take a while. Again, we were resetting in October of '98, and we were heading toward what eventually was 2002. But this was necessary, because open source is, you say meritocratic, you talk about merit. Obviously, there's problems with power and fraud. But ultimately, I think in open source projects, if they're well managed and if they are successful, there is a good meritocratic process amid all the personalities. And that took time to build up and to tune. So when we got into the 2002, 2003 era, we finally released Mozilla 1, something we were happy with. I think Netscape 7 was based on it, and that actually was a lot better than 6, but it was too late for Netscape to regain market share. We also started something then people don't really know about called Mozilla/Browser originally. Blake Ross, who ended up at Facebook, and Dave Hyatt, who's at Apple, created it, and it became a popular early project as just a browser, not a whole suite of applications, which was the Netscape product that Mozilla had open sourced. And somewhere along the line, it became Firebird because of a trademark issue, and that changed again. Dave Hyatt, who was really influential in the early days of Mozilla, wrote a lot of code, and I wrote a new roadmap where we talked about doing just a browser, doing just a mail app, focusing on doing one thing well, also decluttering the app from all the sort of optionality that many open source hackers like. And this is another challenge in open source, that you have people who want to scratch an itch, and they want that, that HP calculator that has too many buttons on it. They want to have something that isn't that approachable to an average user. But we saw that was going to be a problem in growing our user base beyond some point. And yet there's a solution, which is add-ons. Now every browser has them, but we were the first. I think we still have the most. So the add-on architecture was important. The way you write add-ons for Firefox and other Mozilla products is almost like writing web pages or JavaScript and XML. It's very accessible. And at this point, I think we pulled ahead of Netscape on downloads. But Netscape was going down, and AOL finally pulled the plug in July of 2003, and they laid off practically everyone. Some of my friends there are at Google. Some of them took a roundabout way. One of them works on JavaScript nowadays with me in the standards body, ECMA, where we have good working relations with everybody, Microsoft and Apple as well, as good as you can have. But that was the point, and only then where we had an actual Mozilla independent entity, which was the foundation. And it had a mission, which was our mission all along. It was a mission that actually had its costs. For instance, Mitchell Baker was laid off, really fired in 2001. And yet she kept working on the project. And I think she was fired because they wanted her not to be adjudicating in favor of volunteers. And they thought, well, now we fired her, she's gone, we won't see her anymore. And the very next week, there she is in email or on the IRC channels, because it's an open source project. Netscape management didn't really understand that up to that point. I think they learned the hard way. It's important, though, there's this notion of equity. You're not going to get people volunteering if they see a rigged game, unless they're really, kind of sick fans, and then the quality of their work may be suspect. So leveling the playing field was important, and Mitchell carrying on was important. There's even a deeper story there, which was one of these happy accidents of fate, or some charmed life we all lead. Mitchell ended up working for Mitch Kapor, and Mitch Kapor ended up helping persuade AOL to spin us out as a foundation and give us enough funds to go for a while. But not a lot of funds, more than they were going to give us at first. Mitch was very helpful in that regard. 10 people at first, maybe a year and a half, maybe 2 if we squeezed, and that would be heading into the end of 2004, and it would be desperate if we didn't make money. So we had to focus. And open source projects, again, if they're just itch-scratching sort of computer geeks, maybe they're not focused. Maybe they're rewriting the same code for the umpteenth time. And that is a problem, I admit, in open source. You get people doing things as sort of recreational pastime, and it may not be productive. And I think this is a problem in Linux in particular. Much as I'm an old Unix hacker and I like Linux, the state of the desktop environments on Linux has just not progressed. So we had this new roadmap. We were going to do just a browser, just a mail app. We were going to have add-ons. We were going to reduce the feature complexity, the user-facing complexity, make these very slick products that would be appropriate for experts who could add add-ons, but also for the average consumer. And this was a little controversial. Some people really liked the suite, and they stuck with it. But we slugged it out, and we fought on, and we managed to get Firefox together, and it started to really go. In the middle of 2004, I think it was very clear it was going to gain a lot of market share. And fortunately, we didn't run out of money. We found we could make money through search partnerships, and we did that. And it was in Google at first. We tried Yahoo, and it didn't quite work. We knew that that was possible because Safari had been launched by Apple and already had such an arrangement. So we were also finding that people using Firefox were very valuable users. They weren't just more expert with the computer. They were also doing more productive searches in terms of ad click-throughs, apparently. And that was important to learn. And the focus on end-user usability, which is a little unusual, and Windows portability and integration to make it a good product on Windows. You don't see that too much in open source even now. And I think it hurts open source uptake, because I think the theory is you switch to Linux operating system and then the apps will follow. But switching your operating system is a big cliff to jump off of, as opposed to just switching your browser, especially if the browser that you're switching from isn't that good. And I think it's well known. I was not in good shape at that point, which helped us. And I don't think it was just us. I think Opera maybe could have done this if they had been open source, which was impossible with their relations with handset makers and carriers, and if they had gotten rid of those ads they had at the time in their free version. But they didn't do it, we did it, and that helped restart the browser competition and the evolution of the web, I think. And it's moved on since then. It was also 2004 when a bunch of us were at a meeting in San Jose, a W3C meeting about compound document formats, and it was a lot of XML people, some of whom were trying to sell products, and they were saying, oh, those browser vendors, they don't get it. The messy tag soup, unspecified error correction. Everything should be XML, it'll all be better. We'll rewrite the web. And so a bunch of us who didn't believe that for a second went to have a beer afterwards and said, no, let's do HTML5. And that's how the WhatWG formed, which fed its work back into the W3C, and now we have that great thing I showed at the beginning, HTML5 with hardware acceleration. So it was a productive year, and I think having the leverage of a fast-growing browser was important. Opera was a good partner in it. Apple didn't come out from behind the cloak at first, but they were also involved in the WhatWG founding. We all were kind of small market share at the time, and it was easy for us to say, let's try to move things. What did we have to lose, really? And the open source aspect was not peculiar to us. Apple had it through their work on KHTML, which was, in some ways, they were not managing that relationship as well. They were not running the community in a way that was friendly to the KHTML people. They were instead sending very large patches every 6 months from Cupertino back to Germany or Norway, and I think the reverse was happening too. So that's kind of a counterexample, and that led to Apple finally doing the right thing. This is a long story I can't tell here, where they formed webkit.org, which is now the place for what was KHTML, and everything's back together. And it's a pretty healthy project. In some ways, they cloned Mozilla. and they have a pretty clean code base, so they're doing well. Chrome's using it. I'll skip that history, but this is NetApps. Their numbers, which may not be legible, are a little conservative, especially in Europe. They're off, but we've grown ever since, and our growth has flattened out, but we're still growing, which is nice. So I wanted to talk about what we have to contribute to, let's say, software engineering. Software engineering has always been kind of a tainted phrase ever since I was in university. It seemed like there wasn't enough engineering, as in kind of formula a civil or mechanical engineer would use. There wasn't enough quantification, but there certainly is data to learn from and to steer your processes and your development by. And program analysis we believe in, so I'll get to that. We somehow in the last 3 or 4 years have managed to average around 35% volunteers, even though we've grown, we've hired a lot of people ourselves. This is the usual power law problem, the Pareto income distribution problem, but we haven't hired 80%. We're more like 70 or 60 on a good day, so that's good. We still keep working on growing the volunteer community, bringing in new people and bringing them up, and it's critical because otherwise that code rusts and your old timers leave and you lose knowledge. It's a very large code base, multiple millions of lines. We have maybe 700 volunteers active within a year, not always active day to day. We have many locales. I think we're much better localized than our competition, and that's only going to grow. We seem to have good local engagement around the world where people actually, even if they're volunteers localizing it, they may have some commercial business that benefits from that, and they do a good job and they please their locale. They do good translations of the menu items and so on. So there's room to participate at every level, not just the code, but the translations and the documentation. The 50,000 nightly testers is very important. We get signals from them through automated crash reporting, and we're adding more telemetry over time. That's hugely valuable because the web is so large. You have people on different parts of the planet. Their common reference strings have no URL in common. And then 5 million beta testers was like a high watermark for us this last release cycle, and that's even more valuable because what you find is that, I think Ben talked about this in his nozzle talk this morning, you go to one scale of testing and you see certain results or lack of results. You go to another scale, several orders of magnitude larger, and then you start seeing things you had no idea were out there. You find some bank in Finland is doing something very strange, and you had to get to that scale to reach that user who used that bank and actually reported the bug. So there's a number of events there that have to line up. And the only way to get there right now that we know of is through scale of testing. And we have a lot of users. And we want to grow all these quantities over time and keep them in some kind of balance. Here's a dashboard we've just set up recently. This shows code contributions. In fact, you can see there's a neat little bar here that shows patch, merge, back out. The gray on the right is back out. It's okay to back out. Sometimes you make a mistake, and the prudent thing to do is to back out and try again. People who are productive tend to do this. The #1 guy there is really good, and he actually doesn't back out that much. We're also looking at things, we haven't quite tuned this up, but we're looking at metrics like, are they going inactive? Do they seem to be getting frustrated? Now, this happens to be a bunch of people who are employees. The next one is mostly volunteers. There's a few characters in there like me who got misclassified because of my email address, and we're going to have to work on that. Basically, we have some old-timers and various people who use non-Mozilla.com addresses, and that's we need a big table to equate those with their Mozilla.com addresses so we can treat them as employees. But people sometimes leave the project, keep hacking. People leave the project, hack as volunteers, come back and hire again. We're trying to be a long-lived nonprofit, so maybe it doesn't matter, but we want to make sure we're not privileging the people inside too much, and it's inevitable that you will just from the high bandwidth face-to-face communication that goes on. We do have lots of meetings. We're using video conferencing more and more. We fly people around, including volunteers. Other contributions. The bug system we created to launch Mozilla has been forked and used all over the place. It's rickety in the sense that its user interface is like a 90s web app. You have to wait for pages to load. But the database schema and the sort of dependency tracking make it almost a project manager, and it's what we use, and it's pretty popular in spite of that UI. we do continuous builds, and we always did. We called it tinderbox. You're always burning the tree. That is, you're breaking the build. You're not supposed to do that. These green letters indicate individual builds, and you can hover over them to see what's going on. You can click on them to get full logs and other options. It's sort of a Web 2.0 interface in that you don't have to load the whole page, and it's like a river of text that keeps coming in. The orange letters indicate test failures. That's a problem because we haven't quite eliminated all the non-determinism in our code bases and operating systems. So there are some metastable conditions. We have to work on that because non-determinism means bugs. Something's reading uninitialized memory or something like that. You see names of people who did pushes so you can get individual blame. That's how you know when to back out. This is just the latest incarnation. Other people have things like this now. Mozilla pioneered this as far as I know, and this latest tune-up is pretty good. We're pretty happy with that. Code review and testing, you'll see this now. Google has some very good tools for this. I think they have open source ones and they have not open source ones because of their internal version control system. We always have code review before commit unless you have some really big patch and you have a hard time landing it as an atomic transaction. And if you get lucky, you'll get review after the fact. We don't do design review, which can cause problems. People sometimes do this great flawed design and then write a lot of code, and we tell them go back to the drawing board. That's pretty awkward. We try to get people to talk about what their designs are and have wikis and design documents of that sort, and then when it's time to code, smaller patches more often are better. It's almost always better. There's an overhead to it. You have to break your work down, but it allows you to triangulate on regressions. Since the web is so large, often you don't realize you broke something until weeks later when some bug comes in, and then you end up binary searching, bisecting back through your version control history based on tests run against the automated builds produced from the individual pushes. And you can find the change set that broke that feature and then puzzle out why it broke it, which is always great fun. Something else we were a little behind on, I think other people are better at this, commercially and in open source, but we finally got around this corner, which is requiring tests with patches and automating tests, and that's what all those oranges and greens mean. And that's been big for us. We also have hired a bunch of the Valgrind hackers. Valgrind's a sort of a runtime memory checker, just-in-time compiler, machine-to-machine translator. It's very impressive, pretty efficient, and we're running those continuously, 24/7 Valgrind builds. Valgrind has extra tools for dynamic race detection, things like that. We're using those too. To good effect. These guys are really good. Another thing I wanted to mention, it's a contribution. I think we pioneered this in one respect I'll talk about. It was being done by security researchers before us who were generating travesties of HTML and other markup languages. We've invested in JavaScript fuzzing, generating nonsense programs and illegal programs, programs that have correct syntax but have very, very bad behavior. We actually do let them run and accumulate state. We do things based on the bugs we find. We sort of steer the fuzzer. We add human intelligence into the loop of evolving it, and it really is effective. With one of these expert guys who writes these things, tracking sort of the evolution of the code base, looking where the new code is and finding the soft spots, these things just generate unbelievably complex code that hones right in on those bugs. And as I say in the bullet point, it's more productive than any static analysis approach we've seen so far. But we do like static analysis too. And that's what I'll talk about here. So we started, I think originally I talked to Dawson Engler and he said, come on up and use Coverity for free. And they ended up doing that thanks to Microsoft, I think, lobbying for the government paying for that, which is fine. Show open source's flaws, it's okay. The Coverity flaws are, there's a lot of false positives. You have to teach Coverity or any of these unsound checkers about all your higher level idioms, and you want to write higher level checkers too. We never got to that state with them because they were busy with their, growing their startup and serving their customers. So we really wanted to have our own tools, and theirs are not open source. There was a project at Berkeley, it was a set of projects. Scott McPeak was sort of a C++ super hacker under George Nekula. He did Elkhound, which was a GLR parser generator, and ELSA and Oink. And we started working with them. Pretty soon, Coverity hired McPeak, and that was that. But we forked Oink as Pork, and we hired somebody really good who took over and just started going crazy with it. We tried something early on that was very aggressive. He did this amazing work to do automatic patch generation for C++, which is very hard because there's something called the C preprocessor. And if you're trying to integrate into the compiler an analysis, you're looking after the preprocessor's expanded all your macros into big, ugly hunks of code. He actually inverted that C preprocessor process to get back to the primary source in terms of source coordinates. And that was important because we wanted to say, here's a problematic code sequence that the compiler can see after the preprocessor is run. We want to match that and then replace it in the source with some better sequence. We want to rewrite our code by generating patches. And to do that, you need to invert C preprocessor. He did that. We haven't used it too much. It's pretty hairy, and the tooling, I think, is clunky. But we have generated some patches with it and used them. He then went on to work on GCC plugins, the GNU C compiler, and that was very productive. And the GCC guys just opened up to having plugins, which was good, because in the old days, I don't think Stallman would have gone for it. And it was a very productive partnership, so we built a bunch of tools. We're still using a big semantic grep sort of tool that's called dHydra, a cross-referencer that's aware of syntax and semantics and type names versus identifiers and method names in C++, template parameters, things like that. TreeHydra, which as the name might imply, is actually able to see a reflection of the GCC high-level abstract syntax tree and allow you to script it. These are all scripted analyses. They use JavaScript as a scripting language. They embed Mozilla's JavaScript engine. So you can write these interesting analyses, like someone wrote an ESP one, which I think MSR work. And even though it's in JavaScript, even before all our fancy JITs in the last few years, it was effective at running an analysis. And we found some interesting things in our code. We were looking for, again, this sort of high-level model checking, like does your JIT, which is a trace JIT that fails to reify stack frames, it inlines aggressively into JavaScript functions without building up the interpreter control stack. When it has to leave the trace, you want to compensate by building that stack. But in the meantime, if it's on the trace and it calls some native method, can't look at that stack, can't assume it's there. We wanted to partition our code into functions that were able to look at the stack and count on it being there, and those that weren't, and check that there was no control flow between them. And we did that with this static analysis. So we're believers in this. We're trying to use it, but it has to be practical. It has to be approachable. It can't have a heavy annotation burden. And that brings me to something else. Brian Hackett was a student at Alex Aitken's at Stanford. He started this, I think you interned at MSR. He started this before he joined Mozilla, but he's just a super hacker. He calls it Sixgill, and it is mostly sound C++, C, static analysis that will find buffer overruns and faulty assertions. And it doesn't require a lot of annotations. You might want to change your code if your code is just too confusing for it, and we're working on that. These kinds of tools do generate false positives. So again, this is where the social aspect comes into play. You don't try to be perfect up front. Soundness is not within reach. You instead take the number of false positives you have in your code base today and make that a watermark, and you try to drive that downward, and you try to use public shame or blame to get people to realize that they perturbed it upward and they should fix their code. And we're working on that still. Here's an example where I think it is Sixgill has detected that this assertion is going to be not satisfied in all cases statically, which is nice. I'm not sure that's a false positive. I think that might be true. So another thing we have to contribute that is very new, and I just want to talk about as kind of a lightning talk work in progress. We've started something last summer called Rust. It actually started many years ago. Graydon Hoare developed it. It's a programming language, and we're going to use it for a particular purpose. It's a multi-paradigm language. It's an actor language. It has lots of highly concurrent tasks. They can map to threads or processes. It has an interesting type system that separates the shared immutable memory and the unshared mutable memory, and never the twain shall meet. And it has a type state system, which is an old idea that lines up very well with our idiomatic C++, where programmers write assertions like the one you saw in Sixgill, and they assume those assertions are going to catch bugs in the builds for which they're enabled. Those are debug builds, so-called. But of course, in the production builds, assertions are too expensive. We can't compete with Chrome or IE9. We turn them off. So we take our life in our hands because our debug builds don't see every test input, don't see every possible input. So Rust has a type state system that is meant to be like assertions that are always on. And it allows sort of blind reasoning about pure predicates. It can see, through data flow analysis, it can see when you've checked the condition, and it can know that it doesn't need to be rechecked. So there's opportunity there for hoisting and code motion to make that more efficient. I have some results, though, that are very promising already. Why are we interested in a new programming language? Well, I think we're in the second golden age, and there should be more programming languages. I don't think that we have enough, personally. In fact, Go came out after we already were working on Rust inside Mozilla, and we were worried for a second, oh, Go, there's no point anymore. We should just give up. But Go, unlike Rust, doesn't seem to have a modern type system. It doesn't have anything like type state. It has null pointers and mutable state. Well, it's up to you to protect yourself from that. It's sort of a Unix hacker language. It's very much like Rob Pike's previous languages. So we think Rust has a reason to exist, and it's not just safety, which we're very concerned with. It's also parallelism. And that's why we're looking at building a parallel browser engine, inspired by the work at UC Berkeley under Ross Bodick. And we're starting this now, and we're taking a different approach in some cases, like the DOM, this crazy object model that I created in a hurry in 1995, which then got layers of standards heaped on it. This set of APIs is actively called through by JavaScript, and it builds a model which then is put through a layout process to turn essentially widths into heights and locate where floats should go, things like that, table layout, and eventually paint that to your screen. It turns out a lot of the commerce is between JavaScript and the DOM, and if your DOM is in C++, that's a lot of crossing the language barrier, which is expensive. So we have a DOM that's being prototyped in JavaScript, and it actually is faster than our native DOM in some cases, which isn't totally surprising in this day of fast JITs, because the JITs can trace through or inline aggressively, and there's none of this barrier crossing where you have to marshal the arguments and manage the type conversions between JavaScript and C++. So we're really concerned about many core. It's coming on mobile quite fast because of the power wall problem. And we think Rust is a good general purpose language, but we're not out to sell it or promote it. We're not writing blog posts about how great its syntax is. It's really something we're trying to use, and it's very young, and its syntax will change. And the fact that it doesn't have too many outside users that we know of is good. That would be a big constraint, but it is open source. So here's an example, just to suggest what's going on. We have a module system. We have ways of importing native functions, like the square root there. This is the nbody benchmark from the Great Language Shootout, which is not a very good benchmark. You can see that sort of an ML-flavored language syntactically. There's no example of type state here. There's no task. This is just a single task program. But using LLVM for code generation, we're actually getting good results. The Rust results are up top, and 1.69 seconds versus GCC getting 1.481 seconds. We're getting close. And there's some extra safety checks in there that are hurting us. I think the square root function is not being inlined as it is in the GCC case. GCC does a good job with that. Here's fannkuch from the same benchmark suite. This is a combinatorial pancake flipping thing, and it does really well. For some reason, even with the safety checks, the array bounds checking that Rust does, we actually beat Clang, which is the new LLVM-based compiler coming out of Chris Latner at Apple. We checked this result. It actually is not as good on older processors like the Opteron. This is the Core 2 Duo. There's an excellent branch predictor in there that's just doing a great job. So we're hopeful that we can use Rust as a replacement for C++ at some point. We're not trying to do this next year or the year after. We're simply trying to do something that looks ahead and looks around some corners and is ready for 8, 16, 64 core machines where the cores aren't that fast and yet you want your browser to run fast. And of course, this brings us to formal methods. I remember telling, I think Joe Kinnery at Dogstall a few years ago that we at Mozilla like formal methods. And yet, they're hard to use. The community doesn't understand them. Most people aren't trained. You're not going to sit down and prove large amounts of code correct. So we're looking at incremental paths, ways of adding value. I'll try to speed this up here. And we're going to keep working at this. But if it's true that programming is still too much of an art, and if engineering is still somewhat qualitative, we're going to need people to help us with this. And that's where I still have problems bridging the gaps. So let me plow through since I'm a little behind. But I do want to point out that a lot of programmers don't care about engineering. They use things for personal or aesthetic reasons or productivity reasons, valid reasons. And so we're trying to work with that audience of larger programmers and with sort of more expert programmers, people who can do verification. So far behind, let me just speed up. One of the points I'm making here, which you can see on the slides later when they're up, we've come a long way in version control from when we started. When we started, it was hard to manage a project and do parallel development. Now it's easier, and it's not only parallel in the sense that you rendezvous in one true source of truth, but you also can have distributed sources of truth, and that's important. That's helping us engage with more users. So that's where I get to GitHub, which we're trying to work with. They were the sort of sponsors of CodeConf. They have a website that makes it fun to do this. You actually see people's progress. You get to use their code and interact with them. You see requests from them to pull their changes into your repository. You see diffs. You can comment on them. You see who's been changing at what rate. They have very nice graphics. And that's something that we respond to. There's also literate programming going on. Don Knuth, tried to proselytize this, and I think didn't really succeed. It's happening on GitHub. People out there got the idea, and they're doing it. It's beautiful. Here's another example. And this is an open source code culture in action. And I don't know if everyone here has seen this, but I encourage you to take a look. I think there's something real here. And it's something that we need to exploit to cope with the problems before us. We can't simply formalize and mechanize our way past these big problems. We have to somehow bridge the gaps between the sound but not scalable methods and the semi-sound methods like Sixgill or Rust and the unsound world we're in today with C++. So that's my thesis. Thank you. Since I'm short on time, I don't mean to.
Well, thank you very much.
Yeah.
While we are swapping computers, are we going to swap computers?
Same computer.
Oh, right.
Yeah.
Let's take 2 questions.
Joe.
Thanks for your talk. Hint to the audience how they can get more engaged with you.
Switch the microphone on.
Thanks, Brendan. How's it going? Hint to the audience how they can get more engaged with you and make an impact.
So with this audience, I would say mail research@mozilla.org. That mail address works, and that is read by multiple people. And we actually do grants. We're not well-heeled like MSR. We try to do targeted grants. We're trying to do more. We'll hang up a shingle and explain our agenda a little better. We haven't done that yet. But we are open to mail there. It's very low traffic. We're kind of lonely. So that's the easiest answer.
Hi. So when I get on the Firefox website, I see the claim Firefox is secure. And at that point, I say that's not a serious claim you can make. So at that point, that's a reason why I don't want to use Firefox, because if someone claims that their software is secure, I don't believe them, so they're not really serious. What is your answer to
I
that?
tried to get them to take that down. I'll have to try again. Everybody says they're fastest, and except us. I'm afraid we still have that up. That's a holdover from the old days when I think, in relative sense, we were certainly more secure than IE 6 in the 2004 era. Nobody's secure, not even Chrome. So you're quite right.
Great. Well, thank Brendan again for coming all this way and choosing us instead of the other conference.
Thank you very much.
Oh, I get to introduce Tony. Yay.
Microphone. You want a microphone?
Tony will introduce himself.
I don't think I need another introduction. No, thank you very much. No, it's great to be here, and I owe everybody an apology for asking university ethics officers to approve things. And since my old university doesn't have an ethics officer, I do understand how much problem that can cause. So you have my apology. Okay, so it was a really interesting history that we learned from Brendan, and I learned lots of new things. Microsoft's at the beginning of this road, understanding how to work constructively with the open source community. I joined Microsoft 6 years ago, and things have changed dramatically. So what I'd like to do is tell you that the changes, I believe, are genuine, and tell you what I hope are some positive and some surprising things that you may not know. First of all, a little biography. I mean, I, as an academic, did open source. I learned it from Jacques Tongara. One of the things that, this is to show I used to be a real academic and wrote books and stuff like that. But the message passing interface standard, it was an informal standards body. It still is an informal community standard. And it was done in a year. And the reason it was done in a year was because there was an open source implementation that actually progressed as the standard was being developed. And that was absolutely vital. It was done by Rusty Lusk and Bill Gropp at Argonne. And it was a really important thing. And I was really very pleased to find when I went to Microsoft in 2005 that the open source version of MPI was included in Microsoft's HPC product software. So Microsoft from 2005 was incorporating some open source. So standards. So I've been becoming educated at Microsoft, and these are just some of the most popular standards bodies and standards that we work with, and you heard some of them, ECMA from Brendan, and we obviously work with WSI and W3C, and you can look at all the other ones there. But even I was surprised to find that these are the sort of standards, some subset of the standards groups that Microsoft is working with. And so there's a lot of them, and Microsoft really spends a lot of time working with standards bodies. And obviously doesn't please everybody. I'm well aware of that. But this is, if you like, just as an example, Windows 7, the sort of various standards. And so the ECMAScript we heard about, CSS in web browsing, and all these other things. These are just in Windows 7. And I particularly liked this quote. When people hear the word open, they think Windows. Who do you think said that? It amazes me. Okay, so anyway. So really, it's really surprising. So that's the Windows product. And this is Office. And again, they work with a large number of bodies. And there was a sort of controversy between the open document format and Office Open XML. Both are open ISO standards. You can go from one to the other now. And I think they were actually trying to do different things. So the Open XML was trying to deal with the legacy of earlier Word and WordPerfect documents, whereas Open Document Format was, if you like, simpler because it was starting from a blank sheet of paper. And they were slightly dealing with different things. But now actually you can use either, and it's all XML, so you can convert it to one or the other. So Office, one of the projects I was involved with early on in 2005, 2006, was a European project with libraries and archives around Europe. It's a Planets project. It was a very interesting project. And in that, the librarians needed to have some way of being able to have all these digital documents they had, but they needed to be able to preserve it, and they needed a preservation metadata format. And with IBM in the project, with ODF, and with Microsoft using OpenXML, we have conversion tools that convert old formats like WordPerfect and so on to the modern XML formats. And you can either have OpenXML, or you can have ODF, or you can have the Chinese version, UOF, which is the Unified Office format. And you can go from one to the other. So we also funded open source conversion projects. Now, it is perfectly true that things don't always look exactly the same in each format, but they're relatively small differences. So I think we're getting there, that users want a choice, they have a choice. Once it's in these XML formats, they can use any tool they like. Doesn't have to be from Microsoft, could be open source, to actually go and manipulate those things. So I believe this is a really positive step on the road. Internet Explorer, I won't say very much about that, but we've had an up and down road in browsers, as you heard from Brendan, and I certainly found the history of Firefox extremely interesting. But I think HTML5 is a real step forward, and Microsoft have now embraced that, and the Internet Explorer 9 is actually implementing the emerging standard HTML5. This is one that is not yet a standard. It's being used by various companies for actually making their data accessible and being able to use it. It by and large builds on sort of RESTful standards that people already use, and so it's not actually putting much new there, but it's not yet a standard, but it is the sort of thing that I hope will become a community accepted standard. So it's not intended to be necessarily driven only by companies, but actually involve the community. And again, it's building as far as possible on existing web standards. Okay, so those are just some quick view of some of the standards bodies and standards that Microsoft is adopting. And I'm sure you all know that we've now settled our suit with the European Union, and we've documented all the interfaces and so on. So interoperability. Well, these are standard quotations from 2008, again, which might surprise you. Steve Ballmer, our goal is to promote greater interoperability, opportunity and choice for customers and developers throughout the industry by making our products more open and by sharing even more information about our technologies. And I think to some extent we were forced to do that, but actually we have actually done that. And then Bob Muglia, president of the Servo and Tools, we recognize that it's a mixed IT world. And he was hearing messages from the customers that they wanted technologies to work together. You heard from Brendan that people wanted browsers that worked on Windows as well as Linux. And that's what people have in businesses. Our customers told us that interoperability is a significant obstacle and that they need better support, both from us and other vendors, to resolve those issues. So I think Microsoft's actually got the message, and Bob certainly has been in the forefront of that part. With Ray Ozzie in 2008, they had these interoperability principles, ensuring open connections, promoting data portability, enhancing support for industry standards, and fostering open engagement with customers in the industry, including open source communities. So I think there's been a big change that actually Microsoft understands that it needs to work constructively with the open source community. So we have a group that does interoperability, and these are just some of the things that they do. This is around support from Microsoft for PHP in the Azure cloud and Eclipse modernization for Windows. SQL Server supports PHP and so on. So I think there's a recognition that there are standards out there that people want to mix and match, and we have to support that better. And I think Microsoft is now doing that, and this is a site you can go and look at some of the projects there, which I think will surprise you. And so, mixed IT world, in fact, in a survey that was done, they found about 350,000 open source applications running on Windows. All right, so it inevitably is a mixed world, and we do understand that. What about the cloud? Well, I think the cloud is still emerging, and we're involved, as you'll see in a moment, in a European cloud project. And obviously, customers don't want to be locked in. They want to have choice and interoperability. And so data portability standards, ease of migration, and developer choice are going to be key principles. So what's happening in that space? Well, this is from our web page. We're working with various cloud groups looking at possible standards and how VMTF with the Open Grid Foundation and so on. So still emerging, not yet there, but I think Microsoft will support some interoperability in cloud standards. And this is a project that we're doing, you heard about in one of the earlier talks, Venus C, virtual multidisciplinary environments using cloud infrastructures, and that has a lot of use cases. And from those use cases, we will get an understanding of what you need to do to give you some interoperability and portability with the cloud. And so that's done with Dan Reed's Extreme Computing Group in Redmond. So let me come to open source. So when I was in the UK, I was involved in the JISC, and one of the things my JISC committee, which supported research, put out was a document on open source licenses which explained open source licenses. What the choices were. I mean, I used to be Dean of Engineering, and I used to have to explain to my engineers about open source licenses. Now, I didn't care which they used, and I happen to believe if it's publicly funded, it's not unreasonable that code you develop is open source. But, you know, they came to me and they said they really wanted to make this the next MATLAB or the next Fluent or whatever. And it does depend what open source license you choose, because you're choosing a business model. And so these are some of them. I have Mozilla down there, fortunately. But the GPL licenses, as it says here, GPL license insists if the software is combined with that code, it must be under a GPL license. So they had to understand that if they worked all their night and they got venture capital and worked 24 hours a day, anything they produced goes back into the public domain, which is fine. That's the Red Hat model. But if they want to build a company like MATLAB, then they maybe want to use a less, I guess viral is the word, open source license. BSD license, for example, or Apache allows you to mix and match, and what the public funded is open source, but then you can take that and use that as a basis for products which are not open source. And so they needed to have that sort of knowledge. And if you see that in the States, this is the National Institutes of Health, National Cancer Initiative. This is the guidance they give on funding from the NIH on open source, and there they talk about these three common licenses. And you need to know the distinction between GPL and BSD, and they don't insist which one you use, but at least they tell you what the choice is. And I did find in my previous life that academics don't know the difference, and it can matter if you're trying to spin off companies and things like that. So, open source at Microsoft, well, we collaborate with all of these people, and we recognize they exist and they're going to continue to exist, and Microsoft really has to learn to work constructively. And again, I'm pleased to see on my slide I have Mozilla down there for Brendan, and we've been working with Brendan. But again, there's some interesting things. I talked about, 350,000 open source projects now are Windows compatible, and there's this statistic which I haven't verified, but it was given to me, so I believe it. 23 of the top 25 most downloaded open source software projects run on Windows. Okay, so some interesting things, and reflecting a reality that the world is mixed and you're going to have a mixture of open source and commercial closed source working together. So, what I'd like to tell you about is a relatively new development. It's about a foundation, and so this is called an open source foundation which was initiated by Microsoft. It's called the Outer Curve Foundation. So what is it? Well, what it tends to do, intends to try and bring corporate IT with different vendors, with the open source communities, in a way that companies like Microsoft, their employees can work safely on open source projects without jeopardizing companies' IP, which is legitimate companies' IP. And so that's one of the reasons for it, and it's carefully worded that enables commercial players. I was interested in Brendan's history of how Mozilla started without a foundation, and it was part of Netscape, but it wasn't part of Netscape. It did sound extremely complicated. Well, this is an attempt to make it simpler, and also not to insist on a particular license or particular technology. So we have Apache, we have Eclipse foundations, which have specific agendas by and large. And so this is intended to be agnostic. You can use whatever license you like, you can use whatever forge you like, and whatever development process. And so it's a vehicle where Microsoft now is putting IP, so the IP is owned by the foundation, it's not owned by Microsoft, and Microsoft employees can actually go and contribute to open source projects that they feel passionate about. So we have 2 seats on the board. I'm one of them. All right? We're outnumbered. We're not the majority of the board. And we also have the opportunity for corporate sponsors. And there's a thing called a gallery. So what a gallery is a range of projects. Let me just, this is the metaphor. So sponsors can create galleries based on a particular set of technologies or a particular problem area, and they're the people who manage the code commitment and what code they accept and so on. And individual projects in this gallery complement the particular theme. So the foundation was not set up by Microsoft Research. It was set up by the business groups in Microsoft originally. So the galleries from Bob Muglia's organization. There's the ASP.NET gallery. Projects are a collection of sponsor and non-sponsor contributed projects. There's a manager and there's a board member who's responsible for mentoring that manager. So that's how the project runs. And there's another one here which is Co-op, which is about package management for open source contributions for Windows, like we already have in the Linux world. The project leader is a Microsoft employee, and it's got over, compared to the statistics that Brendan has, we're right at the beginning of what we hope is a growth curve, so it's a very early days, but we have, a majority of contributors who are not from Microsoft in that things. And the project leader controls the website, selects the forge, manages the contributions, and so on. So that's what we're trying to learn. We're trying to learn how to do this and to work with people who know. So on our board of the Outer Curve Foundation are people from the Apache Foundation and other people like that who know how to do these things. So we're trying to learn. What are we doing in Microsoft Research? Well, one of the things we've been trying to do is what we call research accelerators. It's probably true to say that Microsoft has focused its products on the business and the consumer rather than the researcher. So can we make our products more appealing to researchers? How can we do that? It's not a big business market for the business groups, but on the other hand, it's important to us. And so, for example, lots of scientists use Excel. Can we make that easier to use? Lots of people write in Word, not, of course, so much in the computer science community, but lots of people in the scientific community write their papers in Word. Can we make that easier to do, and can we give them support for the things they need to do? So we're trying to do, therefore, open source projects with researchers. I have a small engineering team, and the idea is not to produce product quality code, but to produce code which is actually documented and tested, which is perhaps better than the open source code that I used to produce as an academic, which was open source, so it works on my machine. Your machine is your problem. So we're trying to do it slightly better than that. What we're trying to do is get these projects led by academics who want this and see value in this, and to build things around Microsoft products. I can't open source Microsoft's products, but I can offer open source additions to things like Word, Excel, SharePoint, SQL Server, and so on. And you saw in the demos, Zentity is a semantic layer built on top of SQL Server, for example, which is going to be open source. So, just a couple of examples. This is a chemistry add-in for Word. It sounds trivial, right? I will do the chemistry add-in for Word. Let me say, first of all, chemistry add-in for Word and the Microsoft Biology Foundation. Just two examples. So let me start with the Microsoft Biology Foundation. That's meant to be an open source library for bioinformaticians to build on so that they can do applications using these open source codes. This is from my director, Simon Mercer. The principal advantage of MBF is that because it's free and open source, as a programmer you get a certain amount of pre-written functionality and you can just build on top of it. Gives you more time to do the real science because we're trying to support the basics underneath. And again, what we'd like to do is to see that the community say, well, what you're missing is this functionality, and we can actually help get that functionality built with the community out there. So that's what we're trying to do. And that currently is being submitted to the Outer Curve Foundation. One of the things that will happen is that its name will change from Microsoft Biology Foundation, since we don't wish it to be specifically a Microsoft product. This is a chemistry add-in for Word, which is led by chemists at the Department of Chemistry in Cambridge, and this is being committed to the Outer Curve Foundation. And Peter Murray Rust is one of the leaders there, and he believes in semantic chemistry. So though it sounds very easy to just type equations in Word, in this case, if you type something like CH4, CH4, because it's used chemical markup language, CML, the actual computer understands that that C is a carbon atom and the H are hydrogen atoms, and it gives you the choice of either calling that methane or CH4 or giving you the chemical structure. So if you like, it's the beginnings of semantic chemistry. So it's really quite exciting and has had several 100,000 downloads. So we're just beginning. We're a long way behind Mozilla, but we're attacking a much smaller audience. So this is the sort of totality of the pictures. And again, we're at the beginning here. We have authoring add-ins for scholarly communication. We have also a Creative Commons add-in. So actually, a Creative Commons add-in, and also so you can actually specify on your slides that you want this to be available under a particular Creative Commons license. We have an ontology add-in for biologists, because biologists like ontologies, and when they're writing a paper, you want them to be able to tag with words in the specific ontology relevant to that paper. You want to be able to tag your document, so make it easier to search more accurately, and that's being done with Phil Bourne and colleagues at San Diego. Scientific computing, we have a number of things. So, for example, we talked about Microsoft Biology Foundation. We have BLAST, NCBI, it's the NIH Institute responsible for the National Library of Medicine. We now run their BLAST code in the cloud, and that's one of the services. So these are not only client, but they're also cloud services. And then we have TriF-Sharp, which you saw here, and Worldwide Telescope we're trying to extend in various ways. And some of you will have seen the demo with Kinect, where you can control Worldwide Telescope with gestures using a Kinect engine. Kinect for Windows SDK. We also have a data service called WebNgram and Spell Checker Challenge, which Evelyn Villegas has been pioneering with the Bing Group to making data available for academics. And Zentity you saw for research management is again at the beginning of it, what we hope will be something that appeals to you. So these are the sort of things that we're doing. We're trying to learn, and if you have suggestions as how we could do better, we would very much like to hear from you. And ideally, we'd like to produce things that you think will be useful for your research. So I'd like to leave you with one specific challenge, which is this one here. So you will see Microsoft Research Academic Search Tool, which at the moment covers mainly computer science, but it's being extended to cover other fields. So if you like, we're going to look at Archive, which covers physics and mathematics and astronomy, and a number of other repositories, as well as the major journals. So it's not going to be just computer science, but at the moment it's mainly computer science. And you can find top papers in computer science. You can search top papers, authors and conferences, detailed specific papers, and so on. And you can do rankings. You can see who's the most cited person, which institution's most cited. You can find out, look up Tony Hay, you can look up Judith Bishop on these things, and you can find, for example, Andy Van Dam. You can find out all the people he's collaborated with. You can go and see who they've collaborated with. And so we're providing a sort of interesting starter functionality. And in the UK, as I said, I was Dean of Engineering, and so I had engineering faculties like civil engineering and mechanical engineering and all these people. And they gave me a very hard time coming from computer science, because we like to publish the things we care about, mostly, are in workshops and conferences. And the engineering professions, the hard engineering, they all publish in journals and think conferences are lightweight. And so there is always a difficulty in convincing our colleagues that we're relevant. Why does that matter? Well, it matters in the UK because they rank each department, and the amount of money you get from the government depends on your ranking. So I was head of department and dean, and I had to go and do these things. And so it became very important to be able to go find these things out. So you can do rankings using the information here, and we've done some for you. But we're going to make open APIs to this, so you can do things relevant to your institution or your country, And what we would like you to do is to suggest what you'd like, and perhaps with you we can build some modules which are open source, additions to this, if you like, add-ons in the Mozilla sense, which can make this more useful for you. So that's what I would like to challenge you, is to see how you could make this more useful for your research, for your community, and for your country in ranking research or tracking research or doing research. So please think about that and drop me an email, tonyhay@microsoft.com, and we'll certainly respond and see if we can provide you with some assistance. So that's really all I want to say about our open source activities. We're just beginning. We have a long way behind what you heard from Brendan, but I think Microsoft, even in the time that I've been there, which is now 6 years, has changed rather significantly. And really, I think you have to be convinced by what we do as a company, but I think you can see that we are engaging with standards, we are serious about interoperability, and we are serious about engaging with the open source community. But we rely on you to help us so we can have a constructive engagement where you win, but also there is some value in it for Microsoft. So that's what I would like to see, if we can engage in that debate. Thank you very much for listening.
Certainly time for questions.
Hi. What is the relationship between outer curve and the CodePlex?
Right, a good question. Okay, so initially the Outer Curve Foundation was called the CodePlex Foundation, okay? But you then needed to know that codeplex.org was not wholly owned by Microsoft, whereas codeplex.com, which is the forge, where a lot of open source projects, which are not all under OSI approved open source licenses, so there are some projects there, but there are also other stuff there. And it was to remove the confusion that codeplex.com is the forge that Microsoft runs, and codeplex.org is a foundation that we don't control, all right? And because we couldn't even explain it to Microsoft employees, all right? So we decided to change the name, and the only name we could find that was uncontroversial was Outer Curve. That's why it's called the Outer Curve Foundation. Right. It does not have all the projects in the Codeplex Forge, because the Codeplex Forge contains more than just... In Outer Curve, they're all OSI approved open source licenses, what everybody would say is a genuine open source license. All right, so that's the distinction. And with the Outer Curve Foundation, you can use codeplex.com as your forge, but you could use Apache, you could use WordPress, you could use whatever you like. You don't have to use Codeplex Forge. I apologize for the confusion, because it is confusing. Brendan. And Evelyn, you can explain about WebNgram better than me.
Thanks. It was an interesting talk. I'll have to have our counsel look into Outer Curve, because having some kind of legal framework for protecting property rights or code copyright is important. That's why I think Mitchell made the MPL sort of weekly copyleft. It's kind of between those two. I had two other points. One was open standards bodies, in my experience, even though they're often approachable for a not-for-profit like Mozilla, they're still kind of a smoke-filled room with an old boys club operating. And so you'll see mysterious appointments of chairs in W3C, which may be Tim or his staff, and it isn't always clear that there isn't a fix in. That seems like a problem. I don't know if you have any comments on that, but that's one thing I raised that troubles me. The other is, you mentioned forges, and I talked about distributed version control systems, which are really peer-to-peer systems, fully symmetric. So there's no one forge. I just wanted to put that across, because I think that really is taking over, at least in the sort of open source code culture.
No, I think we have things to learn, and Brendan, I'll take that back. Yes, okay, so I was involved in one very successful standardization effort, which was MPI. And that was a bunch of us. I wrote the first draft with Jack Dongara. The reason I wrote it, was because at the time, it was in the 80s, there were new parallel computing companies coming up day by day. You wrote your code for this machine, they went bankrupt next day, and you had to rewrite your code for another machine. And it was clear that they were all doing message passing, and there was clearly a need for a message passing standard. People were also trying to standard high-level parallel Fortran, but actually what was needed and what was clearly feasible was a message passing standard. So Jack Dongara and David Walker in the US, myself and Ron Pemple in Europe, there was a real danger that Europe was going in this direction and the US were going in that direction, and I wanted that not to happen, and so we wrote this draft. And once you write a draft, of which we had a birds of a feather session at supercomputing, and I remember my role in that was organizing it with Jack, but also I paid for the beer, I remember, right, on a European project fund, right? So it was a very useful use of funds. And that was a community effort, and it took a year to come to conclusion, but it was actually no standards body, it was just a community of experts. And that really was quite successful, and it's too successful because it's been around nearly 20 years, and we really should do better. But I then, when I did the UK e-science program, the particle physicists in Europe wanted to build a grid, and clearly having interfaces which were standard. So I spent a lot of time over 5 years with a largely academic, but with some industrial contribution, the Open Grid Forum. And I regard that as sort of 5 years wasted time, because I think you need to have the industry involved. Otherwise it becomes, quote, purely academic, using academic in a pejorative sense. Coming back to the standards bodies, yes, I was involved to some extent in the spec benchmarks, and I agree with you, it's not always obvious who decides the chairs, and I mean, there was a lot of suspicion about web services with IBM and Microsoft, were they dividing it up? But, you know, because IBM were patenting these standards and Microsoft were patenting these, but then they both made, if you like, an open specification promise which said anybody can use this, you don't have to, because you do need to have some structure, you don't want too much chaos. You know, everybody, so I think what Microsoft felt in the web services case was that they needed to get things to at least some consensus with some of the major players before it became an open process. But of course, the chair and everything else can have a lot of things. But about the web, W3C, I haven't spent a lot of time with W3C, and it's a curious organization. I did give Tim Berners-Lee his first honorary doctorate when I was head of my department. But yeah, it's a mysterious thing, and I don't know how you do better, all right? But I think you need to have some friends, and you can. It's influencing friends in the big companies and establishing some trust. But that doesn't always happen because there's competition and everything else. So I think there isn't a magic bullet. You know that.
Great. Well, I think on that excellent note, we will thank Tony very much for his talk. Sorry about this. getting there all by myself. It's amazing. Yeah. All right, so okay, so it's my great privilege to complete and wind up this Paris Software Summit. And I've just got a couple of points I want to make. Some of them I think you'll enjoy. So I have some time, and I hope you're going to bear with me while I make these points. The first one is that what was the Paris Software Summit? Well, I was privileged to go into quite a lot of the sessions. Sometimes I was chairing them, so I had to stay awake and actually listen to what was going on. And I was blown over by the quality of the talks and so on. And I can remember, just over these few days, the topics that were covered. I mean, clearly we were dealing with mobile. We were dealing with mobile phones, these wonderful gadgets that many of you got. We had the launch just a few hours after Las Vegas of the Connect SDK. We had verified software, 3 great sessions, another one coming this afternoon. We had the software engineering track that was running through so many of the different talks, and thanks to the RISE group for putting all their people in there and all the wonderful demos they brought out as well. We had Gadgetaire on the first day, and the people who went to that session will be going back to their universities and trying to convince their colleagues that this is something they could definitely use. We had F#, and personally, within my own group, we're now beginning to forge some kind of connection between that and semantic computing, and of course there was the cloud. And right at the beginning, there was that very big, in this room, that very big workshop with all the policymakers and the funders. There might well have been other things which I'm not mentioning, they're in your program, but those are the ones that stick in my mind. And I thought to myself this morning, well, why did you all come here? Because you're not presenting papers. And as Tony said, people go to conferences because they've got to get brownie points. They've got to present a paper, and the paper goes on their CV. And for most of you, this wasn't the case, and there isn't a proceedings. So I think it is a tribute, actually, to the speakers. And so my first thank you at this point is to all the speakers who gave of their time so willingly. No, I don't know a single speaker that we invited who said they didn't want to come and speak. And, of course, to the session owners who organized the different sessions and drummed up these speakers, in fact, the best in Europe. That was really, really important. So now my first bit of fun, which, believe it or not, Tony and I actually have a little bit of a mindset going together. I want to just show you something, which is Microsoft Academic Search. So some of you might not have gone to the booth where this was on display. It is a very, very interesting program that you can use to find out about your rankings. And I'm just going to play a little game here. Of course, it's in a new version. This is not a version I saw until this morning. As you can see, the idea is that over time, Academic Search will be covering all the disciplines in science and engineering and even in the humanities. But we're interested in computer science, so we'll go there. And what you find is that it's able to talk to you or to tell you things about authors, publications, conferences, journals, etc. And it usually lands up on organizations. So to save time, we'll go to organizations. But as you can see, top organizations in computer science are already ranked for us, and they're all the usual suspects. MIT, Stanford, Berkeley, Carnegie Mellon, and fifth is Microsoft. So we'll go to organizations. We will. Yes, we will. Go to organizations. We're there. All right. No, we're not. Oh, more. We've got to hit more, sorry. That's where we've got to go. More. It is going, is it? I did this earlier, so it should have gone. Let's go. No, it's got to go much faster than that. That's what I thought, but that's not taking me there. No, sorry. Okay, so that's what I wanted. All right, now, what I wanted to show you was the following. Microsoft, as you have seen in these talks today, doesn't work on its own. There's no way that the 850 Microsoft researchers around the world could produce the research that we do if all we did was sit in our offices and write papers and do research. The way it's done is we collaborate with people in universities, with INRIA, as there was a great big day here on Tuesday, and we collaborate with people. And through that collaboration, which has expanded under our great leadership over the past few years, and in fact over the past 20 years, things have changed quite a lot. And let me show you how they've changed. So there is a little button here where I can select years. So I'm going to select the last 5 years, right? Hee. I like that. So Microsoft and all of you together, thank you very much, is now top of the list. That's all I wanted to show you about. You want me to show you Europe? With pleasure. Okay, so we go to all continents. This is in, sorry, my finger is sticky. Doing online demos is a skill. Right, we can go to Europe. All years, University of Cambridge, INRIA, UCL, Edinburgh, and Oxford. Same old suspects, right? Last 5 years. Doesn't change much. But Microsoft is listed as a worldwide entity among all of that. Aha, thank you, Tony. Right. So, what I want to do, because this is a question I've received in the corridors as we've been walking along, is saying, well, okay, so you're talking about this great collaboration. Well, how do we do it? For those of you who aren't already collaborating with Microsoft, or those of you who would like to collaborate more, how do we get there? What are the mechanisms? Well, there is a page called Collaboration/Awards, Research Microsoft.com Collaboration Awards, and it lists many, many, many ways in which you can collaborate. It's not a very colorful page. I think we could do better on the color and the pictures, but it doesn't matter. The info is there. So there is a lot here. You can go and spend a lot of time here, find out all the things you need to know, and delve in, look for the deadlines, promote yourself, promote your students, and so on. And there is another page I'd like to take you to. What are you going to do when you leave this conference? Well, maybe you want to tell your colleagues what you did. Maybe you would like to reflect back on what you have done. So, this is the Microsoft Research Connections page, and Connections is the organization which Tony heads up and which I work in. And in this page, you will find that there is a little thing that goes round and round and round. And here is that logo, and this is the Connect logo, that if we go back and wait for the one that we want, right, we can wait for it, we can click on it. Come on. It will come. By the way, there's a nice interview with Bill Gates there, a video which you might also like to have a look at. There's a lot to see on this page, in between all this other stuff. Oh, meantime, we'll go here. This is Tony's blog that he put up yesterday. A very nice story about what was happening at the conference, a whole load of interesting thoughts that he had about what was going on and so on. And you can look at it and see what is available and so on. What is also available for you and for everybody are the free tools and technologies that you've been downloading onto your phone, and you can get these. So we have to go back now to this. Right. Yeah, this is the page I wanted to get to. So this is the new landing page for the Software Summit. And down here, you will find that there are the featured tools and technologies, the ones you've been hearing a lot about. And they're all available to get to directly from this page. Picks for Fun, Rise for Fun, Try F#, Academic Search that I've just shown you, and so on and so forth. And we'll be adding a few more to these. Not only that, and this is something you've, as academics or perhaps for your students and your colleagues would like to know, all the videos which we've been taking of all the sessions, the slides and so on, will be loaded up onto this page. So that'll take us a few days. We can't do it overnight, but they will all be coming here. If you don't remember where this page is, don't worry. You go to research.microsoft.com. From there, you can find us. All right. And you will be hearing from us because you will get a questionnaire which will ask you about the conference. We hope you will all answer it. You can, of course, contact us. You can contact me, Jay Bishop. You can contact Tony, as you know. And, of course, the hosts of the conference, who were Cambridge and Andrew Herbert. You're very welcome to contact him since he is your European person. And so it leaves me just with one very, very pleasant duty, and that is to thank the people who made this conference possible. We could not have done it without the amazing help of the events team and our technical staff. And so at this point, I'd like us all to give them a very big hand. I'm going to call the summit to a close and invite you all to go out and have lunch. Of course, it's not really a close because this afternoon we do have 3 very interesting sessions, and I had the very strange, unusual comment from somebody this morning who said, "Oh, I've changed my flight." I said, "Oh, you're going early." He said, "No, I'm going later. I want to stay for one of the sessions this afternoon." So the rest of you, if you want to do that, of course, you're very welcome as well. And see you at lunch, see you in the sessions, and hopefully see you next year, Tony. Thank you.